Hello everyone, welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to explore machine learning lifecycle, right? So that's what we're trying to do. So I'm just calling this machine learning lifecycle 2.0 just for fun, to make it interesting and exciting. So the traditional one that we know of, right, which is what we are still using, is this simple image here, which is this one, right? So for you to do any machine learning project or for the complete lifecycle, you first of all have to have a problem you want to solve, right? Then you gather data around that particular problem, right? So you make measurements of the things of the world to be able to gather data. That's the first step. So the first thing is start with not data, it starts with the problem. So you start with the problem you want to solve, then you collect data around it, then you prepare the data, then you do some data cleaning, then you analyze the data, you build models, right? And then you test the model, you evaluate the model, then you deploy. This is a simple, basic machine learning lifecycle, right? Now let's move on to the 2.0, right? I'm just calling 2.0 to make it interesting. So don't worry, this is going to be available for everybody to have access to it. So this is it. You can also be adding your own to it, right? So this is a simple one. So machine learning lifecycle 2.0. So as I said, all of them start with problem, right? So after getting a problem that you want to solve, you gather data. So these are the main stuff. So I have this 4 different aspects of it. We have the data, the one with the star. We have the feature stage, right? We have the model stage, and then we have the product, right? So the product is going to be the solution or the problem you want to solve, right? So first of all, we have a problem you want to solve, you gather data around it, and then with the data you'll be trying to build features. Then after building the features, you're going to feed it into an algorithm to build a model, and after feeding into the algorithm to build a model, a powerful model, you will now build a product from your model, right? That is the most important thing, which is going to be used to solve a problem, which is going to use to generate profit and to make money. Yeah. Okay, so let's start with it. So we'll be starting from data, right? So the first thing that you must collect data. That is the most important thing. So there are several places you can collect data from. You are trying to simulate the physical world, so you have to make some measurements. You're supposed to use sensors, you're supposed to use images and a lot of things to gather data. That is the first stage. Then after that, you just move on to the second stage. So the data they are collecting can be in different formats, right? I don't know whether I can say it all. It can be in different formats. So the first one is that the data can be in different formats. So it can be based on the different types of data format that you have, right? So it can be either it is a binary data, right, in case you are getting from logs. It can be media data, right? So media data means that you are getting it as either audio, video, or images, right? Or any other future media, maybe virtual reality media that is going to come in the future. So these are the different types of data. So based on the data format, we can have binary data, that is ones and zeros coming from machines. You can have media data, which can be video, audio, or images, as well as any other thing that will come in the future. We also have textual data, right? That is also the other format of data. So textual data can be in in different formats, right? For the textual data, we can have it in the format of let's say text, right? In several formats. It can also be numerical data. So these are the main types of data formats that you'll be working with, right? Perfect. Then after that, it can also be based on the structure of the data, right? Or a predefined model, if there's a model in which the data is collected to be. So it can be in a format of structured data, as you already know, which is following a predefined format: tables, rows, columns, predefined. Unstructured data, which can be in the format of images, videos, text, right? It can be semi-structured. So in semi-structured, it can be emails, it can be JSON format, right? It can be web pages. So this is based on the structure, whether it is following a predefined format or not, whether it's in the format of tables and rows or it is not, right? So structured is predefined format, unstructured is no defined format, and this is easy to create. Unstructured data is easy to create and collect, but structured data can be difficult, right? You're supposed to make sure that everything is in row, is in the predefined format. Then semi-structured can be in the format of JSON, XML file format, right? That is a basic understanding behind it. So that is the two main things. So based on the data format, based on the structure of the data, right, which can be structured data, unstructured data, or semi-structured. Then it can also be based on the storage, right? Data storage. So where are you storing the data, right? Or where are you getting data from? Is it from a database, or is it from it can be NoSQL database, can be SQL database, it can be any relational database, is it from a data warehouse, right? So a database is different from a data warehouse, and is it from a data lake, right? Or is it in the cloud, or is it on-prem? So if it's a data warehouse simply, it's like we have database first, lower level, that is what we use, right? Then we have data warehouse, right? That is the next level. Then we have data lake, right? So the data lake is the largest of them all, right? In another way, it's like a lake. So it contains all types of data. It can be structured, unstructured, semi-structured forms of data, and it is very, very scalable, right? And the procedure for data lakes is that it is usually you extract the data, you load it, then you transform, right? So in other words, like whatever you're going to do is schema on read, right? So data lake is very, very huge, very, very. Something like Snowflakes is a data lake. Like BigQuery can also be a data lake. Like some of the S3, Amazon S3. So there are several data lakes, or Delta Lake as in Databricks. So that is the first level. That is the highest of them all, data lake, right? Which is huge, and it is low cost. You can store petabytes of data there, right? And usually it is all types of data. Then we have data warehouse, so which is the next stage. So for data warehouse, it is structured, it is ETL, and then it's schema on read. Then you also have databases. So the data can be stored on your system, or maybe in your premises on-prem, or in the cloud, right? That is what everybody's moving. So let me show you an example to help you understand the difference between data warehouse and then data lake. So this is a simple image I got from BMC, right? Which is trying to explain what we mean by difference between database, data warehouse, and data lake. So based on the data, we have most of the time, most databases, relational or whatever it is, NoSQL database, are structured, right? Then we also have a data warehouse, which is also structured, right? Because I said it is database, data warehouse, and a data lake. And data lake is raw, unstructured types of data. All kinds of data can be in a data lake. Then for the processing, we have to a schema on write. You have to write your schema, like predefine them. Whatever your query, your questions are going to be supposed to be predefined, right? The same thing with data warehouse, but this one it is done on read, right? Then most of the time databases are free, right? But data warehouse can also be costly. Can be costly more than data lake. Right, so that is a big difference. So most of the data warehouse can be costly, right? Because it's really structured. Then data lake are very low cost, right? Then we have the agility, varies, minimal, maximum. Then for security, most databases are mostly not matured in security, but for data warehouse, and then data warehouse has mostly matured. That's why it is more costly. Then data lake is also immature. Then for the databases, anybody can use it, but you require an IT or business user to work with data warehouse, and we require a data scientist to work with a data lake or data engineer, right? That's a basic understanding. So most of the time for machine learning, we have machine for data warehouse, in which everything has been structured well. Then you're just getting it from the data warehouse to do whatever I want to do. So this is a simple difference between them, and then their drawbacks. Let's go back to our stuff. So you have seen the different types of data based on the data format, based on the structure, and based on the storage, right? We can also have based on the task. So this is very important. So we can have data which you are going to collect because you are doing a machine learning task, or you are doing a deep learning task, or you are doing statistics tasks, right? Normal statistics, BT statistics, time series, all of these things. Or it can be for NLP, or it can be for computer vision, can be for any other thing. So for NLP, we can have several packages in case you want to do your machine learning project. We can have the Almighty Spacey, very powerful. We also have Stanford NLP. We also have Spark NLU, which is a very new library from John Snow Labs in collaboration with Databricks, and then Spark, very powerful library. We have FastTest, we have TestBlob, we have Flare, very nice library, and we also have the Almighty and the ancient of days NLTK. We have Gensem for topic modeling. We have LNNLP. We have for visualization, we have Word Cloud, TestVist, Scatter Test, and there are several of them. Okay, so when you are working with test data, you also have to make sure that you know some test cleaning packages to help you clean your test packages you're cleaning, to do some test cleaning. So some of them include, we have Teddy Test in case you're coming from R. We have Test Hero for Python, Neat Test, that is a package that we developed, that's why I placed it there. We have regular expression, very, very important to understand regular expression because it's very useful. We have Clean Test package, we have Fizz Test for you. Right, so these are some of the packages that you'll be using, right? Very simple packages. Okay, so let's go back again. These are based on a task. Now, so we are collecting data based on the task, and this is how we can do that. Okay, so let's go back again to ingestion time. So there are data types based on your injection, right? That is how you receive the data, right? So it can be either historical or real time. So historical data is data that you have collected for some time, maybe 1 day ago, some hours ago, right? But real time data is coming in seconds, right? Which is usually useful for, that is streaming data, which is useful for online machine learning, right? So these are the basic difference, right? So we have seen something about the data, right? Now let's move on from the data to the data exploration. So you have gotten your data, you have seen the different types of data. Let's move on to the data exploration, right? So for data exploration, you're supposed to explore your data. Okay, so for the data exploration, so after getting your data, right, in case you want to explore it, so this is one of the packages that you can use to help you explore your data. We have Pandas, the almighty Pandas, a very essential tool that you need to master. We also have Jupyter Notebook, which is a rapid development environment in which you can actually use to explore your data set. Very essential. We have Pipolar, so we have PySpark in case you are working with very huge sums of data, or Spark. We have Koalas, which is an intermediate between working with data that Pandas cannot handle, that is too small, too big for Pandas, and too small for Spark, right? So in that case, you use Koalas, right, which is built by the same people that build PySpark. We also have NumPy, which is very important for numerical computing. We have data tables from H2O. We have Data Forge, which there's going to be a video tutorial on that in the future. Some of these things we have already covered in our channel, so you can also check the playlist for some of them. We have Data Forge, which is for JavaScript. It's very, very nice library. Then the rest, right? So in case you want to explore your data, these are some of the powerful packages to help you explore your data. Now let's move on. So after exploring your data, doing some simple EDA, we can also, it is very essential to visualize your data, right? So these are some of the libraries. We have Plotly, very exciting library. We have Seaborn. We have the almighty Matplotlib, right? Matplotlib has some very cool features that if you don't know, you may think that it's a very bad library, but it's a very powerful library. We also have VigaLite. We have Altair. There are a lot of libraries, right? That's why I place etc. So you can also be adding your own to it. Okay, so that is it. So you have explored your data, you have visualized your data to get insight, using line plot to understand relationship, using scatter plots, using, let's say, box plot to identify outliers, using heat maps to identify correlations. We'll be talking about that in the future. Okay, now let's move on from there. So I have finished with the data stage, right? So this is the data. You have gotten the data, you have understood the data, we have visualized data. Now let's move on from the data to be able to build a model. So the next stage in between them is the features, right? The urgent version now, right? Perfect. So let's move on to the features, right? So the features is very important, right? Without data is important, but without proper featureization or feature engineering, right, you cannot build very powerful models, right? So features, right? So that is the next thing on our stuff. So we have gotten with the data. We are now trying to build features. So the process of building features is feature engineering. Feature is different from a data, right? Data is anything, right? Feature is something that makes meaning to your model, right? If it doesn't make meaning to your model, if it's not making meaning and it's not useful to your model, it's not a feature, right? So that's the difference. So anything that is inside the column section or the fields, they are just data, they are just fields, but you have to make sure that it is useful to your model. That is when it becomes a feature. Okay, so let's see, right? So how to build features. So that is a process we call feature engineering. And then feature engineering consists of these steps. First of all, it consists of feature extraction, in which you have your raw data, you're going to extract features from it, build something meaningful and useful to the model. We have feature creation. Feature creation is similar to feature extraction, but feature creation is mostly an automated process, right? This is usually manual, but this is usually automated process, right? Feature creation, in which you are automatically creating features from whatever data that you have. Then you also have feature selection, right? So after you have extracted the features, you must select the most important features, because not all the features are important. So that is the concept of feature selection, in which you may use several tools to select the most important features that is relevant to make your model more performant. Then sometimes, right, after doing all of this feature extraction, feature creation, feature selection, you'll have to do feature hashing, in which you are trying to reduce the size of the feature that you have to smaller size, in which you can use to help improve your model, right? So that is feature hashing. But the next stage, right, after building your feature, which is the 2.0 of machine learning, is what is called feature storage, right? So in the past, most of the time, this is a new concept, feature storage. We just build your feature, you just send your feature straight to your model, right? But the feature storage is the next step. Let me show you a picture to help you understand it well. Okay, so this is something we'll be talking about in the future, so be staying tuned for that. So the feature engineering is whereby you're trying to take your raw data and to build features in which you can use to build your model, right? So in the past, anytime you build your model, right, you will just go straight away and then you train it, right? But feature storage allows you to be able to pick the features that you spent time to extract, to select, and to create into a storehouse, right? So it can be in the format of CSV, NumPy, Packet, TensorFlow, records, can be any format, right, in which you can store it offline or online, right, in the cloud or inside the feature store, so that anytime you want to build a new model, right, so there's some data that said that you can use to build different types of model for different types of problem, right? So in that case, you just pick those particular features, then you train a model, right? So in case you also want to train a different model, or maybe you first build a regression model, you want to build a classifier model or build a different types of model, you don't need to go through the same process, right? Again, right? You just go to your feature store, then you pick the relevant features, then you train a different model. So that is a basic understanding. So this is a very new concept, very useful to avoid repetition and to make your work easy for us, right? Okay. So that is a basic understanding. So we'll be going through that later on. So that is what is important of feature storage. So there are several feature storage packages that we can use to help us. So let me bring myself here, right? Okay, so some of the feature storage packages that we're working on, I don't know whether everybody can see it. I hope everybody can see it. Hope it's not small all along. Okay, so we have some of the feature storage packages that, as I said, we can store the feature online, right, in the cloud, or we can store it offline locally, right? Then we have some packages and some libraries and some services that allows you to be able to store your feature. Among them is we have feature stores from Hopworks or Logical Clock, very powerful. It's from Hopworks, right? From Logical Clocks, right? Very powerful library. We also have feature stores. My camera went off here. We also have Feast, right? Feast is also from a collaboration with Google and then Cogex, right? A very powerful library, which is the first open source stuff. And we also have Feature Bank, which is the feature stuff that is coming in the future, right? Later on. So these are some of the libraries that you can use to help you store your features. Very, very powerful, right? You can also create your own custom, and several companies like Uber, like let's say, like Uber, like Netflix, all of these powerful like startups and corporations have their own custom feature storage in which they used to store their feature. Some of them store their features in BigQuery and then the rest. So that is something very simple. So this is a very important concept, a very, very important thing that you have to master, right? Which is a new stuff here, especially for the feature storage here. That's something new. Okay, so you have analyzed our data, you have built features, we have stored them inside our feature store. The next thing is to move to our model building stage. Right, that's going to be the next thing on our agenda. So let's go back to the model stage, right? So in building a model, there are several stuff. You first of all have to build your model, first step. And in building a model, these are the steps. There are different ways of building a model, right? Several. It can be online model building, in which you are using libraries like Kramer or River or Scikit Multiflow to build incremental models online on the go, real-time streaming model building. We have batch machine learning or model building, in which you have your data already from your data warehouse or from your database, which you have analyzed, or from your feature store, and then you are building your model, that is batch, right? Then you can build classifier models, you can build regression models, you can build unsupervised machine learning models, you can build neural network models, different types of model, right? So this is based on you, based on the problem, and based on the technology at hand. Then it can be component based, right, in which you do it one after the other, or you do it in a preferred way, which is pipeline based, which is the 2.0, right? Most of the time you do it component based, but later on it's better you do everything pipeline, so that the model now is not the product, now the pipeline is the product, right? The workflow is the product. So this is about model building, right? Then some of the libraries that you can use to build models, right, is that you can also use apologies that this was too small. I think this is better now. Let me bring myself down because everybody have seen me before. This is me. right? So in case you've not seen me before, this is me. Okay, so in case these are some of the libraries to build machine learning models. We have the frameworks and libraries. We have XGBoost, very, very powerful for gradient boosting, which was a very powerful library and a very powerful concept that was winning in most of the Kaggle competitions. We have PyTorch, the almighty PyTorch by Swala, very, very important smart guy. We have Scikit-learn, right, which is the almighty Scikit-learn, my favorite, which is simple for everybody to know. We have TensorFlow, very, very cool, supported by Google. We have PySpark, right? So PySpark is mostly useful for big sums of data, and then one of the powerful platforms you can work with PySpark is to use Databricks. Very nice. It's working with the Spark technology, which is very, very nice for distributed computing and then distributed machine learning. Of course, there are other packages like Cafe and then the rest, right? But these are the ones, right? The common ones. If you master these things, you are good to go. Okay, so this is for the libraries for machine learning, for building models, right? Now let's move on from here to the next stage on the model. Still about the models, we have, after building your model, it's important you are supposed to evaluate your model, right? So in evaluating your model, you have to be, in case you are doing classification problem, you're supposed to check for the accuracy of the model, do a classification report. You must do cross validation, model validation. You must check for the ROC curve, precision curve, confusion matrix, F1 score to check for the performance of the model, MCC, Matthews coefficient, Matthews coefficient score, right, which is very important to help you know, which combines both the precision recall, true positive, true negative, false negative, to give you the right metric, right? Sometimes if you depend on only accuracy, you may be wrong, right? So you need MCC and F1 score, right? And you also need some other metrics. So this is for the model evaluation and then model metric checking. You can also do cross-val validation and do all of these things. So you have built your model, you have evaluated your model. So the next step is you must also interpret your model. That is part of the 2.0. In the past, most people do not interpret their model because they see the model as a black box, but now it is recommended for you to interpret your model, right? So how do you interpret your model? So in interpretation of your model, we have two aspects. We can have model specific interpretation, we have model agnostic. So model specific means that it is specific to a particular type of model. So it can be, an example of a model specific library is a tree interpreter, right? So tree interpreter is a powerful library. There's a video on it which will be coming in the future. We can check our Patreon channel or check the courses for it. So the tree interpreter, right, allows you to be able to explain specifically only tree-based model, right? Not linear models, not SVM, only tree-based models. So in that case, it is tree, it's a model-specific interpreter or model explainer. Then we also have model agnostic, which we have a lot of them. We have Sharp, very powerful library using Shapley values. We have Lime, local interpretable, Lime, very, very nice. Eli 5. And we also have what if tools. We also have TensorBoard for neural networks, right? And the rest. So these are the two main ones. So model specific, model agnostic. We can also have neural network interpreters. I don't know whether the spelling is correct. Interpreters. I spelled it wrong. Anyway, we will still continue. So we have TensorBoard, we have what if tool, and then the rest. So it is very essential to interpret your model, right? You to know why your model is making that particular prediction, so that people understand and be able to trust your model, right? Very, very important. So it's not enough for you to build your model. It's not enough for you to evaluate your model. You also have to interpret. And the new aspect of model building, which is part of the 2.0, is also the model bias checking, right? So some models can be perfect, performant and everything, but it will be biased, right? That is in case the data set is imbalanced, in case there is some processes that are not right? How sampling bias, imbalanced data set, how the data set was skewed or collected. So this is very important, model fairness checking or model bias checking. So this is very, very important, right? It's a very, very important concept. I remember there's some of my courses which I did not know that the model was biased. So someone reported and I have to check it and go through it, and I realized that the app that we built was actually biased, right? It was giving a particular type of prediction for contraceptive prediction, and it was giving bias, right? Because the data set was biased. So you have to do model fairness checking or model bias checking. There are several metrics. So there's also videos you can check in the links below or on the website or on Udemy. And maybe in the future we'll be loading it for everybody to work on. So some of the packages we can use to help us do model bias checking is E.Agbe. Very nice. It is an auditing tool which allows you to be able to identify the bias in a model as well as to be able to rectify them. We have Dataset, which is a very powerful library, very powerful, which is also supported in R and then also in Python, that allows you to be able to not just identify bias, right, but also to be able to interpret your model. So it's for bias checking as well as model explanation or interpretation. Dataset, right, very powerful library. We have AI 360, which is from I think IBM, yeah, which is also a very powerful library to help you identify bias in your model. We have Felon, very nice library. We have FairML, also very nice, and the rest, right? So these are some of the libraries we can use, or the frameworks we can use to help you identify bias in your model, and also some of them to rectify them. Okay, so that is it. So you have built your model, you have evaluated your model, you have interpreted it, you have understood that there are bias inside, you have rectified them. Now the next step is to move on to your most important aspect of it. The reason why you went to collect your data is to be able to deploy your model as a product, right? That is the next stage. So you have finished with the data, the features, you have moved on to the model. Now let's move on to how to convert your model into a solution, into a product that you and I can benefit. So the only way we can do that is to use model deployment, which is part of MLOps. We'll be going into that. So in deploying your model, we have several ways of deploying your model. There's a whole video on several ways in which you can deploy your model. You can deploy a model as a web application. You can deploy a model in a format of Docker. You can deploy a model as a CLI. You can deploy a model as a package. You can deploy a model as an API, right? Based on your need. So for deploying your model as an API, which is very useful. This is useful in case you want to save. I feel that this is one of the best ways, and it's very convenient in case you want to build one model and then apply it on different platforms or different machines. So in case you build a model to be able to classify, let's say, messages, or to classify SMS, or to classify something, right, or to do something else, to classify text, or model to predict churn, right, you can deploy it on mobile apps, right? You can deploy it on websites, you can deploy it on IoT devices, based by converting them into an API, so that you just expose the endpoint of the model as an API, so that anybody can have access to it, right? So like something like computer vision, most of Google's product, Google's translation API, right, it's a model they are built, but they exposed it as an API so that anybody can have access to it. The same with the cloud computer vision API. It's an API that has been exposed and anybody can benefit, right? So that is a very convenient way of trying to convert your model into a product that can serve a wide variety of people, right? So as an API, you can use Fast API locally, you can use Swagger, or following the Swagger format, Open API, can build it as a REST API, and then the rest, right? But Fast API is very nice and it's trending now, so you can learn it because it's useful and it's fast, which is based on Flask and then Swagger, right? Then you also have REST API, the normal RESTful APIs, in which you can build as you want. Okay, now let's move on from there. So you can deploy your model as an API. You can also deploy your model as a package, right? So an example of deploying your model as a package is something like Spacey. So Spacey is an NLP library which is having a model, pre-trained model behind it, right? That can be used as a package or as a library, right? So anytime you are using Spacey, you are using actually a pre-trained model behind it. The same way with Transformers, right? So the Transformers library is pre-trained models which has been converted into a wonderful library or as a package that you can use it to do whatever you want to do, right? The same thing with Spark NLU, just working with pre-trained model, right, which has been deployed as a library, as a framework, which you can use. And most of the transfer learning concepts, mostly they deploy the model as, let's say, as a package, as a pre-trained model that you can actually use and retrain. Very nice. Now let's move on from there to deploy your model as a CLI. You can also deploy your model as a CLI, right, as a command line tool. If you can do it as a package, you can also do it as a command line tool. So sometimes some people don't like this, they want it to see it physically. So in that case, you can deploy your model as a web application. In that case, which can be in the format of using the almighty Streamlit, right? That is my favorite. Very simple, very simple to work with. So deploying your model as a web application, you can use Streamlit, which is very simple to work with, right? So there's a lot of videos in the channel in which you can check, and there's also some courses on working on Streamlit. We also have Flask, the almighty Flask, very powerful, simple to learn. but Streamlit is more simpler, right? But Flask is also simple and it's old. We also have Django, which is a full. Django is not a micro framework. Django is a full stack framework. Flask is a micro framework, but Django is not a micro framework. It's a full stack framework, right? So most of the time, people that don't want to go into this aspect, they just go with Flask or Streamlit, right? There's also Gradio. Gradio is also a new upcoming one, which is also simple to work with. Yeah, a very, very nice library. We also have Panel, right, which allows you to be able to work in your notebook. And you also have Express. You can use, this is for JavaScript, Express, Quaz, and the rest, right? So these are some of the ways you can deploy your machine learning model as a web application. Perfect. Now, the next thing that you should learn how to do it is also to learn how to deploy your model as in Docker, right? So once you're able to master this, you can deploy your model in anywhere. So Docker is a containerization software that allows you to be able to package your software together with all the environment, together with everything that you need, so that you can run it anywhere without having the headache of it breaking or it crashing, right? So Docker makes it easy for you. So being able to deploy your model in the format of a Docker container is very, very essential, right, for you to learn. It's going to make your work very, very easy. Then after that, if you're able to do it in Docker, you can now move it to any model 7 infrastructure, right? So some of these model 7 infrastructure include those that can be in the cloud, which can be on edge devices or on premises, right? So on the cloud, we all know the almighty, these powerful ones. We have, first of all, let's go with AWS, right? Which is a very big cloud platform in which they have several model 7 infrastructure which you can deploy or your model on. GCP, right? You have Cloud Run, Cloud Engine, App Engine, and the rest. Kubernetes Engine. We have Microsoft Azure. We also have Alibaba Cloud. We have Yandex Cloud, right? We have HashiCorp Cloud Platform. We have IBM. So there are several different cloud and then powerful model 7 infrastructure libraries available that you can work on. We also have ETC. So the ETC here represent, there are some powerful platforms like DataRobot, Databricks, which provide you with the means of not just building your model but also saving your model on the go, right? So there are a lot of them. That's why I put them as ETC. So in case you have any idea, you can also add it there. So these are the main ways of saving your model, right? Perfect. Now we have seen how to convert your model into a product. You are done. But let's move on to the 2.0. So for the 2.0, after doing all of these things, you must monitor these things. That is where ML Ops come inside, right? So ML Ops is a very new concept. It's old, but it's new. It's DevOps for machine learning, right? So it is just like DevOps, development and operations. So ML is building machine learning models in an operation. How do you serve your model, right? So in that case, I divided them into several aspects. It's a still new concept. I just divided them to something to make it simple. So we have ML Ops, right? Which is, I think I have a picture for that. Yep. So this picture I got from mlops.org, right? That is why I got this particular image from. And then this is talking about machine learning operations, right? So just like DevOps, but it's for machine learning. So it consists of 3 main elements. We have the design stage, we have the model development stage, and you have the operation. So the design stage is whereby you're going to get your problem you want to solve. You fetch the data, you get your problem you want to solve, you get all the requirements for engineering, all the use cases, what you're supposed to prioritize, what you're not supposed to prioritize. It's all part of the design, right? And data availability, right? What are you going to check for? Where you're going to get it? Where you're going to get your data set from? Are you going to be working with data engineers, database, data warehouse, all of these things, right? Then later on, you do your feature engineering. You come to your model development stage, right? That is the ML aspect, which is your data engineering and your ML model engineering, right? Data injection, data transformation, data cleaning, feature engineering, model building, model engineering, model testing and validation. Then the operations is mostly the machine learning model deployment. How do you deploy your model, right? So in that case, it's going to be you can just do normal deployment, or you can just include CI/CD pipelines, and then you also have we have CI/CD, right? And then you also have another thing that I'll be talking about later, monitoring and trigger. So this is the main concept about machine learning operations. You have the design stage, you have the model development stage, you have the operation stage, right? So this is something very simple. So let's go back and see. So I divided them based on those concepts, based on those principles into this. So we have the monitoring stage, right? And we have the experiment tracking, we have the application, we have the automation, and then we have the life cycle management, right? So these are the main stuff there for the machine learning operations, right? MLOps. So let's go with the monitoring. So after deploying your model, you must always monitor it, right? So what are you monitoring? So first of all, you'll be monitoring your model. So you are monitoring your model to know whether it is doing what it was expected to do. You are checking for model drift or data drift, right? You're going to check for the performance of the model, whether it is actually giving predictions. And in this stage, you also be logging your model, logging the predictions to be storing them somewhere, right? Very important, which you can also use to retrain the model. It's not enough for you to monitor your model. You also have to monitor your pipeline, the entire pipeline. As I said, it's always easy to do everything in pipelines, right? It makes your work easy. So you should also be monitoring the pipeline, the entire workflow, which you have automated. Then also be monitoring your data. So you're not monitoring just the model. Yeah, you should be monitoring your features. You should be monitoring your data, right? Checking for data drift, concept drift, which is you should be talking about data. So sometimes your data will change. So once the data change, your feature changes, the interpretation of the model can also change, right? The model result is going to change. Sometimes what your model, the meaning for your model or the problem you're trying to solve can also change, which is also going to change your features, right? So you should also be monitoring that. And then you should not only just monitor your pipeline, your model, and data. You should also monitor the system, the entire infrastructure that you are running on. Because sometimes everything will be working well, but your infrastructure will not be performant. So you should also monitor the infrastructure. That is your system itself, the entire system, the data ML system, as well as the infrastructure that you are working on, whether it's on cloud or something else, right? So this is some of the things about it, right? That is for the monitoring stage. Very, very important. Then for the experiment tracking. So experiment tracking and versioning is that since sometimes you'll be trying to experiment to find out something, you should always be tracking your model, right? So in doing so, there are several libraries that can be used to track your model, the entire life cycle, monitor your model, to version your model and data. So we have the almighty ML flow, which is an experiment tracking, allows you to be able to log whatever thing that you are doing to track the progress of it, which is still part of the monitoring. We have weight and bias, a very, very powerful library by the similar people, same people that worked with Streamlit to create Streamlit, the same two different parties. Yeah, weight and bias, very nice library, which allows you to be able to track your model and track the entire life cycle, right? So some of these things here can also be used for the lifecycle management, right? Not just for the experiment tracking. We have DVC, that's the data version control. You should also version control your data, right? And as well as the entire stuff, to know if there is data drift, to know if there is some changes, right? And you also have Neptune AI, very powerful library, powerful platform, not library, that allows you to be able to do experiment tracking as well as life cycle management of your model. We have Sacred, we have TensorBoard, we have Voha. There are a lot of libraries. You have Seldom. And one thing you should not forget, you should also track what you are doing. So this is experiment tracking and versioning. You need Git, right? You need to make sure that you have a versioning of your code as well as your data in Git, right? So you can use Git large storage system, or you can use Git to store your notebooks and your code, right? Very important. This is very, very important. The origin version, certainly important. Okay, so that is some of the libraries. Now let's move on from here to application and system monitoring. So we have some libraries which sometimes since you are building a web application, right? You can build a web application. You will need to use some libraries or some softwares, frameworks like Prometheus, Grafana, and the rest to be able to monitor your system and the application itself, not just the model, the entire system and the application, right? So that is where Prometheus, Grafana, and the rest come inside. Then let's move on from this place. So from here we have seen how to do these things. Now let's move on to automation, right? Before we move to the lifecycle management. So MLOps, as you said, it is design, machine learning, development, and then deployment, right? Operations. So one of the ways to make your work easy is to automate them. So automation is a very, very important concept in DevOps as well as in machine learning operations. So to make it easy, we move on to automation. So there are several things you are supposed to automate. So the first step before you even automate is you must go through the manual process, right? Design of your entire system, development, right? You do everything manually. so that you know the steps, right? Everything manual. Then after that, you move on to automation. So after doing everything manually, you convert everything into pipelines. So you have your data pipeline, you have your ETL pipeline, you have your feature engineering pipeline, you have your model building pipeline, you have model deployment pipeline, all the different pipelines. Then you automate them, right? It's ML pipeline automation. Then the next step is that since nowadays models can also be seen as softwares, yeah, so you have to do CI/CD pipeline, right? So continuous integration, continuous development, right? Pipeline automation. Then the next thing, which is part of 2.2, is we also have CTCM automation. So this is only for machine learning. This is for software in general, but this is for only machine learning. Continuous, did I spell it all? Continuous training and continuous monitoring, right? Which is still part of this release. So you should also not just CI/CD, but CTCM, right? So there's CI/CD, continuous integration, continuous development. Then there's also CTCM, continuously training your model, getting new data, retraining it over time. Continuous monitoring to know whether there's drift, whether there is performance leakage, there's data leakage, there's all of these things, right? So these are the things you're supposed to automate. First, you get your manual process, you automate all the pipelines, you automate your CI/CD, you also automate your CTCM. So that is for the automation. These are all part of the ML ops. Then the final aspect, which is for the entire life cycle that you have done so far, right? So there are some platforms that allows you to be able to manage the entire platform, right? So we have SageMaker from AWS, which allows you to be able to manage the entire life cycle, all that I'm doing, all that I'm talking. We have Pachyderm, we have Kubeflow, we have Voloha and Vita AI, and there are several platforms, several AI companies that allows you to be able to do all of them. Like Databricks can allow you to be able to do all of this, everything together in one platform, making it easy for you. There is DataRobot, there is Snowflake. Yeah, Snowflake is mostly for data analytics, SQL analytics. There are several platforms that allows you to be able to do everything together, right, in one place, so that you don't move anywhere. Okay, so that is for life cycle management, for the entire life cycle. Then for the life cycle management, we also have some workflows libraries you can use. We have Airflow, we have Metaflow, right? I think Metaflow is only for Python, Airflow is for general, right? So that is a basic understanding. So this is the machine learning lifecycle 2.0, right? Very, very huge. So you can get access to this thing. I think I'll share the link below so that you can also try it out, or you can get the PDF or the file to modify, right? So that is all my talk. So in case you have any question or contribution, you can just put it inside the comment section below and let me know your opinion. Maybe some of them I was wrong. Yeah, maybe I said some stupid stuff. You can let us know in the comment section below. So all of them start from data, right? Start from problem first, data, right? As you already saw it here. As the first thing. The next one, that after getting your data, you must explore your data. As you have seen these packages, you must visualize the data to get insight from it. You must move on from there to build features, right? Very important. Then even in building the features, we also talk about feature storage, which is a new concept, very important, in which you can store it inside a logical works, HSV, Feast, feature bank, feature stores, and custom from different companies, right? That's what we know. And then that is part of the feature engineering stage. Then move on to building your model. And in building a model, you can use it component based, single, pipeline based, can be online, incremental like Creamy, River, batch, scikit-learn, TensorFlow. You can build classifier models, regression models, neural networks, and these are some of the libraries we saw: XGBoost, PyTorch, scikit-learn, TensorFlow, PySpark for big stuff. And then we also, that's for the model building. Right? It's not enough for you to build a model, you must also evaluate your model to get the performance of your model. As we saw here, this model evaluation back here. Then after evaluating your model, you must also interpret it. We saw model specific, model agnostic. Let me know about the correct here, but I know that these ones are correct. Then also another important concept which is part of ML's lifecycle 2.0 is checking for the bias, right, of the model. We saw some of these libraries about to do that. Then the next stage is to deploy your model. So you can deploy it as an API, very important. You can deploy it as a package, as a CLI. You can deploy it in Docker. You can work on model 7 infrastructure like AWS or these particular ones. Then you can also deploy a model as a web application using Streamlit, very important, Flask, Django, Gradio, Panel, Express, and the rest. That is for the model deployment. Then after deploying model, you should also move on to MLOps, monitoring, experiment tracking, automation, and then system monitoring, and then the rest, and then lifecycle management, right? So monitor, you track, you version, you automate, you monitor the entire system, and then you do management of the entire lifecycle, right? Which you have seen how to do that. So that is something simple that you have learned in this wonderful and exciting tutorial. So in case you have any question or contribution, you can let us know. I also have some courses that you can also check to help support the channel. There's also some materials on Patreon. You can also help support it. So thank you for watching. See you in the next session. Stay blessed.